Okay, here we go with box plots. Remember at the beginning of this section, I said that there are 4 graphs. We did a dot plot, a stem and leaf plot, a histogram, and now this is the 4th one called a box plot. And we saw it on Staplet, but I want to show you how it's actually drawn so you understand what it means, and then we'll use technology. Okay, so we'll check this graph with Staplet once we are done. And I wanted to go back to our a data set we've already looked at, which is the one we graphed at the beginning, which is the 15 exam scores for a fictional Stat 243 class at PCC. Okay, so a box plot has some different names. Sometimes it's called a modified box plot, and you always want to make sure the outliers are shown. That's what makes it a modified box plot, and that's the one we want in this class. We want to know if something's considered an outlier. Another term is a box and whisker plot. And I'll show you why it kind of looks like that. Okay, so we have our set of data here, and we've got the steps outlined. So let's follow the steps. Step 1 is to collect your statistics. So this is based on the 5-number summary. And then we also will want to know the IQR. So this is a good opportunity to practice our 5-number summary again, just to get a better idea of what it means and how to do it. So we need to start with our median. That's the very middle. So I'm going to go first and last, then the next to this first, next to last. I keep going, working my way inside until I get to the middle so I can see how many are in the middle. Okay, we've got 1 in the middle. So we have an odd number, so that makes sense. So our median is 82. Okay, and this is points. So this is test score, so points. And then, remember, we don't include the median in our upper and lower halves. So if it's odd, we just leave that point out. If we had an even number, we would split the middle too. Okay, so now I'm drawing brackets around the lower half and the upper half, and we're going to repeat this process and see how many are in the middle. So I'm going to do the 31 up to 82, then 62 to 81, 65 to 76. Oh, yippee, we have just 1 in the middle. So this one is a nice example that might have happened on purpose. So our first quartile is 71. That means there's a quarter of the data below 70 points. A quarter of the students scored below 70 on the test. A quarter scored below 70 and 82. A quarter scored, we need to find our Q3 to find the next quarter. So 87 and 100, 88, 98, working my way inward, 89, 95. That gives us a third quartile of 94. So that means a quarter of the students scored between 82 and 94, and another quarter between 94 and 100. Okay, so let's write out our 5-number summary. The only things we need to add to that is our minimum, so our smallest, and our largest, which is our max. And those are the 5 numbers for our summary. So let me write that out. 31, 70, 82, 94, 100, and then I'm going to write points at the end. It could be kind of tedious to write the units 5 times, so 1 time is generally fine. Okay, great. So our box plot is based on the 5-number summary, but we do show if there are outliers. So we don't want to draw the ends just yet. We're going to start in the middle. And I have a grid here on the paper to help you out, or in the Word doc. If you're using the Word doc, you could use shapes to draw it. And I want to go again, we're at 31 to 100. So I'm going to start at 30 and go to 100. So it's important to draw an even scale first. We don't want to just put our 5 numbers in, because then we can't see how wide each part is relatively to each other. So let me see if I start 1 in, 30, 40, 50, 60, 70, 80, 90, 100. Okay, that's as good as any. So I'm going to start 1 in with 30 and then write 40, 50, 60, 70, 80, 90, 100 along the bottom on the horizontal scale. And I'm going to write my context variable in units. So stats 243 test scores in points. Sometimes people use parentheses for the units instead of in. That works just fine. Okay, so we've determined our scale and drawn the, we haven't drawn vertical lines yet. The next thing we need to do is draw vertical lines at the median, Q1, and Q3. So the middle three of the 5-number summary, that's the box part of the box and whisker plot. So you might want to just start with the median. Now 80 to 90, I'm going to go relatively, 82 would be just a little bit past 80. And the height doesn't actually matter of a box plot. It's really a one-dimensional graph. So there's no label, there's no frequency or no label on the vertical axis. So you can make it however high you want. I'm just gonna, there's 1, 2, 3, there's 5 rows here in this grid. So I'm just gonna do the middle 3 just to make it a nice picture. So this is our median of 82. And then I'm going to go down to 70 and I'm going to draw another vertical bar at 70 at the same, with the same height. And I'm going to draw at 94, so just under halfway between 90 and 100. So I have my 3 vertical bars at 70, 82, and 94. And then I'm going to connect those at the top and the bottom. So we have a bar with a line in the middle, essentially, or like a box with a bar in the middle. You can see the middle 50%, it looks kind of symmetric with the median halfway in the middle of the box, but it won't always happen. Sometimes the median is way to the left of the box, sometimes it's to the right of the box. So that all that helps us determine the shape. Okay, so that's the box part. Now I'm just going to label the numbers right above it, but this is just for reference in your notes. You don't have to do this every time. And besides, you'll be using technology anyways. But just so for reference, this is Q1, median, and Q3. Okay. Okay, now we are going to go out and draw the whiskers, but first we need to determine if there's any outliers. Okay. So let me make sure I did all this. Connect. So I drew the 3 vertical lines, I connected them to form the box, and I labeled the horizontal axis, and I included the scale. Okay, so we got that step all done. The next step is to determine whether there are any outliers. So the rule for this uses the interquartile range. And remember, the interquartile range is the width of the middle 50%. So it's actually the width of this box. I don't think we hadn't calculated it yet. Oh yeah, we're going to do that in step 1 actually. Move that back down. I jumped ahead. So it also said and calculate the IQR. So let me go back up here and do this. The IQR is Q3 minus Q1. So I'm going to subtract 94 minus 70. Let's see what that is. 24 points. Okay, so the width of this box is, because it goes from 70 to 94, the width of it is 24 points. I'm going to draw that. Again, this is just for reference. That is our IQR. It's the width of the middle 50% of the data. Okay, so we use this rule of 1.5 IQRs. So if a data point is 1.5, so here's my 24. Now if I go 1.5 times that, I'm just going to estimate with my fingers, 1.5 times that. So if any data point is 1.5 times that away from the box on the upper side or away from the box on the lower side, then that's considered an outlier. So you can see we might have an outlier down here. Okay, so first let's figure out what 1.5 times would be. You can do it two ways. You can either calculate that first, or you can just use it as part of the formula. So the formula is the upper fence is Q3 plus 1.5 times the IQR. So it goes 1.5 IQRs away from the upper side of the box. And then the lower fence is Q1, so the bottom of the box, and subtract, so you go down 1.5 IQRs that way. Okay, so I will do it that way with the formula. But if you construct the box plot, then you kind of have a sense of what the fence formulas are, and you don't have to memorize them. So our upper fence is 94 plus 1.5 times, you could put a star, I'm going to use parentheses, and our width is 24. (94) plus 1.5 times, oh sorry, I had something in there before. I had to clear it out. 94 plus 1.5 times 24 is 130 points. Now notice we didn't have any students above, you can't go above 100 generally, so we're not expecting really outliers on the upper side. Also because it's skewed to the left, so we would more expect outliers on the lower side. So let me write out the lower fence formula. We're going to start at the bottom of the box, so 70 minus 1.5 times 24 is equal to 34 points. Okay, so that is how we determine outliers. We use 1.5 times the IQR on each side of the box to determine the fences. Any data outside the fences are considered outliers. The whiskers are drawn to the nearest data values inside each fence. Okay, so we're not going to actually draw the fences. Think of them as an invisible fence. Have you ever had or seen an invisible fence? We don't draw them. It's just an invisible boundary. Anything outside there is an outlier. Okay. Another way to think about it is fences are not data. We only want to show the data on our graph. So we don't really talk about the fences. They're just a guideline, but they're not actual data. So I usually talk about and draw the data. Okay, so what you could do is just draw a little, 130, 100, 100, 110, 120, 130 would be way over here. So I'm just going to draw just like a little dotted line. And then 34, I'm just going to put a little dotted line. 34, just for reference. It's not actually part of the graph. Okay, so then step 4 says draw lines to the nearest data value inside each fence and make a short vertical bar. Label each value outside the fence with a dot or a star, and those are our outliers. Okay, so we've got our box here, and then kind of in the middle of the box, up, down, in the middle is where I'm going to draw my line. So that's kind of why it's called a whisker, because it's almost like a whisker coming off of a cat's face. So halfway up the bar, I'm going to draw a horizontal line, and I'm going to go out to the maximum. So our max was 100, and I'm going to draw just a short vertical bar at 100. So that's the upper whisker there. Okay, lower one's a little harder because our fence was 34. We need to go back to our data. Do we have any outliers? We do. 31 is below 34, so that's outside the fence. So 31 is an outlier. So I'm going to write that under my fence here. So 31 is below the lower fence. We don't have anything above the upper fence. Okay, so 31, we're going to mark that with a dot or a star. so right at 31, I'm going to go same horizontal about halfway up the graph. I'm going to put a dot at 31. Okay, now we don't connect our whisker all the way to 31. We want to go to the next data value. Okay, so what's after 31? 31, if I go back to the original data, the next highest was a 62. Okay, so notice we're not putting the 34 on here at all. We're going all the way up to 62. We just want to see what the data show. So I put a little vertical bar at 62 and then a horizontal bar back to the box. Interesting, huh? So that's our box plot, or box and whisker plot. So you can see the box plot, if we don't look at this outlier at all, it looks pretty symmetric right here. There's 1, 2, 3, 4 parts, right, for the 4 quartiles. But then, of course, we do have to include our outlier. So this makes it skewed to the left, right? Because this is, if we go from the middle to the 31, it's much longer than from the middle to our maximum. So I'll put max on this upper part at 100. I'm going to put the min inside the fence. And then we've got our outlier right here, which is 31. Put 62 just for reference. So notice that the 34 and 130 are not in the box plot. Okay, now we did this before. We used the same set of data, so let me bring it back over. So I brought over my Staplet app that we used before, and we had typed in the variable name and our whole data. We're keeping this input on raw data. Begin analysis. We did this in a previous video where we had the dot plot, but now I want to look at the histogram and the box plot again. Now that we know what a box plot is, look at how this matches our notes. So we have this little box plot kind of up to the right. Oh, I will switch the bin width to 10 because we did that. And then here we have 31. If I hover over it, we have 31. Now I think the scale isn't quite the greatest. It does hover on 30. If I hover over it, it says 31, but it's not quite above 31. It's more above, it's closer to 40. So I don't know exactly what it's doing. I wish it was more exactly to 31. And same thing with the 100, so it's a little bit squished in, but we're going to go with it because this is the best technology that I've found, the best applet that I've found to do these. And let's double check our 5-number summary while we're at it. We have 15 numbers. Our mean, I don't think we did for this data set or standard deviation. We used a different one for that. But our minimum, so our 5-number summary, we had 31, 70, 82, 94, and 100 points. Okay, so we matched up. So please do use technology now that hopefully you have a good understanding of what the box plots do. And then in the next video, we're going to look at unusual features and put it all together in a paragraph. Okay, so we're going to put all this stuff that we've been doing together. Okay, I'll see you in the next video.